Alright, so welcome to Static Modeling of Mechanical Systems, which is MME 211. I will be your instructor this summer. My name is Professor Mark Sidebottom. If you need to reach out to me, you can reach out to me with my email, which is just mark.sidebottom@miamioh.edu. So we're going to get into a little bit about the applications of the course in a little bit, but I want to just get through some administrative things just to make sure everything is clear. The most important resource that will be available to you in this course is to look at the lecture handouts that are available to you on the Canvas site. It will give you all the information that you need to know, what chapters in the book you need to read, what quizzes and assignments will be due, what topics are you going to be covering in the lecture, any learning objectives, so basically what you should be able to do or perform after the class. It will tell you what homework problems are that you will have to solve and what the answers to those problems, and it will also give you the common example problems that I will cover in the videos, and also give you the answers to those example problems. I highly recommend that if you have access to a printer at home, to try to print out these handouts before you watch the lecture video. So if you can print them out, that would be great. And I would definitely recommend if you can buy a binder or something to keep all these handouts organized. Okay, so just to show you what these handouts look like, is that they look like this section, this handout here. All right, so to access these, so they have different pages. They have the homework answers. They have the discussion boards. What's nice about the handouts is they basically have an outline for the lecture, all outlined, so you can just watch the videos and you can kind of just fill out the handout as you go along and take notes when you need to. So in addition to so where you can find these handouts is if you go to the syllabus page on Canvas. So go to the course, and then if you click on the syllabus page, what you'll notice, and it's the same as the home page, is that within the lecture number there'll be a lecture handout, which is the screen I just showed you, and there will also be something called your lecture notes. So if you click on the lecture notes, what that will bring up is a PDF that is structured almost identically as the lecture handout, but it will be filled out. So it'll have additional information. So if you miss something on the video, you don't have to worry about it. You will be able to pick it up, or you will be able to write it all down here, or you can look it up here on the lecture notes. Okay, so that's that, and then in addition to the lecture notes and the lecture handouts, all of the discussion boards and the quizzes that you'll have to take, there'll be a link to those as I start developing the course a little bit more. More links will show up. So basically everything you need will be available on the syllabus. The one exception to the thing that won't be posted on the syllabus page is the only thing that's not posted here is videos. So for videos, what you need to do is you need to go to the media gallery page. Okay, so if you go to the media gallery page, there will be currently right now there is no media that's been posted, but I will post this video and additional videos on the media gallery page, and you'll be able to find them. They will be titled by the lecture number and the topic name, and so that's how you can find the specific topic or the specific videos you need to watch. All right. So in addition, so going back to the PowerPoint for this class, you're going to be there should be two methods of evaluation. Evaluate quizzes, which will be 85% of the total. There should be 20 during the summer term, so there'll be 3 to 4 quizzes per week. They will be typically give you around 30 to 45 minutes to do a quiz, and your lowest 3 quizzes will be dropped. The quizzes will be based off of the homework and class videos. And then in addition to the quizzes, you'll have discussion board participation. So these are going to be like informal exercises to test your knowledge and identify areas that you need to review. You're going to submit a couple of times a week, and submissions will be graded based off of like a good faith effort basis. So I'm not trying to grade it for correctness, and I'm just looking at the fact that you put good effort in and that you're trying to just honestly evaluate what parts of the class you need to work on and what parts you understand well. Alright, so in this course there's no homework that is graded, I should be precise. So homework solutions will be posted on Canvas. It's expected that you try to attempt the homework before you get done. So just to show you real quick, the homework problems are available through Canvas. So if you go to back to the home page of the course, you can go down to, there should be a list where under homework there's going to be a homework problems only page and a all homeworks combined page. So if you click on those two PDFs, so I'm going to click on if you open the all homework, so this is going to come up for the homework problems. So if you look at the homework problems, so they're all from the 12th edition of your textbook, and you can see is that there's a bunch of links. So depending on what chapter homework problems are assigned, you can click on the specific chapter, alright, and it'll give you a list of what problems, and it'll give you all the problems, okay? And then the same thing for chapter 2, chapter 3, and so on and so forth. And then the last thing is that if you're looking for answers to some problems, you can click on these links here, and you can see that there's the answers to certain homework problems are also available through this PDF. In addition to that, we have this is the homework. This is all the homework solutions. So if you look, so for each of the assigned homework problems, I wrote out a bunch of homework solutions for each of the chapters. So for example, for your first homework assignment, you can look at these pages here, and you can follow them along and see and check your work to see if you got the correct answers or not. Okay. All right. So that's it for homework. In terms of your grading scale, it's a standard grading scale. You can look it up. It's posted on the syllabus page. So the one thing I do want to mention is that for Miami students, you must get a C- or greater in this course in order to be able to register for MME 312. Okay, so the reason we did this is because there was a high correlation of student success and graduation from the program. So we want to make sure that success in this course leads to success in other courses going forward. All right. One last thing is that I will report any cases of academic dishonesty. So if you do anything in terms of I will outline what resources will be available on quizzes and what resources will be not allowed on quizzes. If you consult a non-approved resource, that is considered academic dishonesty. A resource can be a person, a website, a book, or anything that is outside of what has been approved for the use on the exam. So if you have any concerns about that, please reach out to me. And that's about it. Okay, so for this course, we're talking about mechanics. So this is how rigid mechanics is a part of physics and engineering, which really focuses on how bodies are affected by forces. So mechanics can be split into rigid body mechanics, deformable mechanics, and fluid mechanics. So statics is a branch of rigid body mechanics. It is typically the first course that is taught in your in mechanics for mechanical engineers. So for statics is really originally founded by Archimedes, and then was reinforced really and formalized by Galileo and Newton, and then was an additional was based like further applications and other things were developed by Euler, D'Alembert, and Lagrange. All right, so so in short, this class is really just an in-depth application of Newton's first and third laws using vectors and vector operation. You're going to use a lot of geometry in this course with this focus on trigonometry, and then you're going to use elementary calculus as well, mostly integration for this course. All right, so some of the applications of Newton's first law in terms of mechanical systems deal with trusses. So trusses can be used both in machines or aircraft, but it can also be used in a most traditional sense, which is like for structures such as roofs and bridges. Additional applications are machines, so you can go from very simple machines we can understand with statics, such as levers, or more complex systems, such as the elevator systems that you've shown on the right. And then frames are used typically to transmit or withstand loads in multiple locations. So this is an example of a construction crane, that frame. And then for last couple applications are for screws and belts, which are used to apply to increase force to lift a car, or to apply a brake to a rotary wheel or a machine. All right, so that concludes this video introducing the course.